Hello, my name is John, and today I'm going to re-record a talk that I gave at the Handmade Software Development Pittsburgh meetup. And the topic of today that we're going to do is input, playback, and capture. And the reason I'm doing a re-recording is just because I wanted to polish some things and maybe say some things a bit more accurate than I did there. And I added some improvements to the code demo that I gave there. So I'm going to quickly demonstrate the feature in the game. I'm going to show some examples of different use cases that you can use this feature other than the one I particularly use. And then I am going to get into conceptually how the feature works and then some code examples. So here is a little platformer game that I have been working on with some art you may be familiar with this character running around here. So what I am going to do is I am going to I'm going to go over here, and I'm going to hit a button on my keyboard, and it is going to start recording. You should see a recording in the top left corner. I'm going to play through this level, or just run around the level, I suppose. Boom, boom, boom. Okay, and then I'm going to stop recording, and then it is going to be playing back. And you will see a frame counter up here that is incrementing the frame of the playback. And then it's going to just do it exactly again. And what I also have is a rudimentary way to store recordings in different slots. So if I do a recording like right here, boom, 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 Kirby's on the left and right, and then I stop it, play it back, you should see him do it again. I'm not even touching the controller, just so you know, it is playing back just as you see it automatically. We're going to stop that, then go back to this recording and then play it back, and you'll see that it is the first recording I captured. So I have a mechanism that you could save multiple recordings and play them back. Okay, so now I'm going to go over some examples of potential use cases that you may find useful for this. Now, I am not saying that the examples I am going to show use this feature. They might use it, I don't know, but I'm saying that you can use this to create similar things, and these are things I will probably end up implementing. So in the Sonic the Hedgehog game, as well as many other games, is that sometime they will have an attraction demo at the beginning that shows an example of the game being played without any user input being input. So this is one example that you could use this feature. Okay, so here's another example I wanted to show. In Super Meat Boy, after you complete a level, you have the option to save the replay. So I'm going to do that and save the replay with the X button. Did that save it? Yes, that saved it. So now if we go back to the main menu, we can go to replays and play it back right here. So in the game I'm working on, it is kind of intended to be a Super Meat Boy-esque or very speedrunner friendly. And one thing that's nice is to be able to save replays of things that are timed. So you could save maybe your personal best or something like that. So that's another example of how you could use this feature. So what I wanted to share is how I've personally been using this feature. Let me move my picture up here. Move this over here. Okay. And I've been using it a lot of the times for either debugging or adding some features or adding some polish. So one area I want to inspect right now is in my game. I have something that I guess I'm referring to as ceiling grind. I don't know if that is the official term or if I'm just making stuff up to sound cool, but basically you can grind on the ceiling as much as your jump force would have pushed you up otherwise before falling down. But if you're grinding and then you exit the ceiling, you will begin to fall instead of continuing to move up. And what I'm going to record here is that. And what I sort of noticed is that his falling sprite seems to make him look like he's going upwards a little bit more than I'd like to. So what I'm going to do is I'm going to verify that he is moving up and it's just not me imagining things. And then I'm going to go in and tweak things until it starts to look right. So what I'm going to do is well, first what I'm going to do is I'm going to make this transparent and topmost so I could really see that. And then I'm going to add a breakpoint here. And I'm going to keep holding down the F5 or like just tapping it so he advances. And you'll notice, so sometimes when I'm debugging, it's important for me to see the frame because then I could theoretically add a breakpoint on the problem frame that I'm encountering stuff or something like that. So I'm going to keep stepping, continue until I see his jump sprite change to the fall sprite. So what it seems to me is that his sprite is kind of getting moved up a little bit, and I'm pretty sure that that is his offset causing that issue, like the offset of the sprite in relation to his position. So what I'm going to do is look at his fall, and then I want his offset. We'll try, instead of -15, we'll try -14, right? And I'm going to change that property, and I'm going to continue. And then what I'm going to do is do it again. And I'm holding down F5 now to keep playing. Okay, I'm going to step. Okay, that looks a bit better. I'm just going to try -13 to see if that looks any degree marginally better. So yeah, I think that looks pretty good. Let me just play that back without breaking. Yeah, I think that looks a bit better now. It might have been like a small change, but I think it looks a little better. And you know what? Let me even, while it's like playing, just keep adjusting that. Oh, actually, that looks much better now. And I am just going to slow it down and look at it just to make sure I am not making things up. So he moves along, and then when his sprite changes to fall, I don't notice him going up anymore, like from the top of his head right here. He just moves down. So that is intended, and I like that a bit better. Okay, so what this hopefully illustrated is that I could capture a particular automated thing that I want to test, and I don't have to keep picking up my controller to re-input the things I want to do to test if a particular thing happens again. And this was useful, I guess. Now, it wasn't really a bug, it was more like fine-tuning the positioning of stuff, but I use this feature all the time when I am debugging and when I'm developing, and it actually makes doing things much easier. Like, say I am debugging something, what I could quickly do is keep looping things and add some visual like debug information on the fly to give me more information. So because I find this particular thing so valuable, I wanted to share how you might go about implementing it. And I first learned about this from watching Handmade Hero. I think if you look up live loop editing, that's where I get this idea from. And I'm going to use Odin to show how to implement it, but that the language isn't super important. This could be done in many languages. And as long as the language has the features I am going to show you, you should be fine in implementing this. So I'm going to go over the conceptual overview of how I learned to implement this feature, not how it always needs to be implemented or anything like that, just how I personally learned about it, and I'm going to convey to you. So our game has some concept of a game state. This is persistent state that needs to be persisted between frames. Maybe like level information, the player, any entities, things like that. Anything that needs to be persisted. And what we essentially want to do is have some type of file, which we'll just call the recording file. And the first thing we want to do, because this could really start from anywhere. So let's say I go to level 1, which as you could see is different. And I'm going to play recording 0, so play it. And you'll notice, okay, we are back to the other level once I started playing that recording. So not only does like the position or like the level, but really any state of the game that the recording has started needs to somehow be captured. So when we make a recording file, one of the first things we want to essentially write to this file is that game state, which I'm just going to label as GS here. Then what we want to do is for every frame that happens, there will be some type of input happening. So there's an input on frame 0 from when this started, an input on frame 1 where that started, an input on frame 2 when that started, all the way up to frame N when you stop the recording. And what you essentially do after that is you save, so this is input 0, this is input 1, input 2, and so on all the way up to input N in this file. And when we're writing these to the file, literally what we are writing is the raw bytes that make up this game state struct and the raw bytes that make up this input struct. So literally exactly as it is in memory, we are writing to some type of file here. Now it doesn't have to be a file. You could just as easily be writing this to somewhere else in memory that can get saved and then read back. I am just doing a file because I like the idea of being able to save things that could persist between game runs. And also I think it would be nice to have, you know, a way to save your personal bests or things like that and have those be maintained. What we then do is when we are playing things back, let me get rid of these. So now that we have our recording file saved, when we are playing back, we could just read from the file in a similar manner that we wrote to the file. So we extract this game state stuff and load it back into our memory. So this is our memory or game, whatever. And then on each input for each frame, we will read from the file. We'll advance a little bit in the file and then read each input for whatever frame that we're currently on. So this will need to have some sort of frame determinism in order for this to work, which is probably a good idea anyway. Okay. So now the question is, how do we go about implementing this? So I'm going to show the top level in my game, how it works, and then we're going to go back into each of these functions and see what exactly they're doing. But first, let's see how I am storing all the memory, the persistent memory in my game. So I have a global struct, which is all the persistent memory in the game. And I have some things that are not necessarily part of, so I have some things that are very dependent on like pointer information, such as this, to be quite specific. The game texture that we're writing to, the textures, the sounds, the fonts, a shader that we're using. And these are all under the hood at the end of the day dealing with pointers. And I don't necessarily want to write these to the file because on a next program run, these pointers may be different. So what I do is I keep the actual game state separate from things that are like very pointer specific, like to, that won't necessarily be the same on separate program runs. So here's my game state. And then we'll go back. And also we don't necessarily need to write the recording state to the file because that's sort of maintained outside of the things we want to capture. And some other things is this manual camera position and information about the camera following the player. I put this outside of what we would be saving in the file. And that's kind of because when I was debugging, sometimes I'd want to move the camera around manually while I was doing something, and I don't want it to get reset every loop that we're going through this file, because at the beginning of the file, it is going to read in the game state again. So let's say on record, I'm binding these things to the semicolon and then the apostrophe button for now. So that's just for me. These could really be whatever. So if you start recording, what you'll want to do is that if you press this button, the record button, the semicolon is a record button. Then if it's not recording, it'll begin recording the input. And if you click it again, it'll end recording the input. And also if it's in the middle of a playback, it'll stop that too. So then on playback, it's essentially the same thing, that if it's not playing back, it's going to begin the playback. And if it is playing back, it's going to end the playback. So now let's look at what these are actually doing. Let's start with the begin recording input. So what it takes in is the input recording state, and it takes in a pointer to the game state. So here are the file slots that I can select from. And in the recording state, I keep track of what slot I am in for my particular implementation. So we open up that file name, and then we tell it, yes, it is recording. We set the recording file handle to the file. And then what we do is we get the bytes of the game state, and then we write the bytes to the file. And then that's really it. That's how we start recording. So then what happens is that if we are recording, we want to call the record input function. So this new input is gotten from the get current controller state, so that will get to the new input for this frame. And then what we'll do is we'll call the record input and we'll pass it the new input that we get. So in here we do a very similar thing where we get the new input bytes and then we write the bytes to the same file. And the way the file handling an API pretty much works is that there is a cursor when you're writing or reading from a file. And say if I write, let's just say this thing is like 100 bytes. Well, it's way more than that, but let's just say it's 100. So the cursor starts at 0 at the beginning of the file. And then after writing this, the cursor will be at 100. And then after it writes input, and let's say an input is 20 bytes. After it writes this, the cursor will be at 120 bytes. After it writes another one of these 20 byte inputs, then yes, the cursor will be at 140 bytes. So you essentially keep pushing stuff to this file. Now the reading essentially, and when you end the recording input, you just call close on the file handle, set the flag to false. And the playback is essentially the same thing, but in reverse, where you take in a pointer to the game state and you literally just read in the bytes to the game state and then set some initial state management stuff for the recording. Then for each input, you give it a pointer to the input that you're currently dealing with. And then it just reads in the bytes to the input while advancing that read cursor that I had just talked about as far as writing goes, but it's the same concept for reading, that there is a read cursor that keeps advancing as you read it. And when you read in 0 bytes, at least in my code, I am just assuming that that means you reached the end of the file. There are no more bytes to read. And once you end the file, we end the input playback, which is just closing it. And then we begin the input playback again, which I don't think you necessarily need to close it. You could just, in this situation, you could probably just set the read cursor back to 0 with some sort of operating system seek function. I just happened to be closing it here and opening it again. So we end it here. We begin the input playback again to load in the game state once more. And then we continue to read from it like normal. And you'll notice here what I also do during the playback input is I increment the playback frame. And I at least found this information to be valuable to me when I'm debugging, particularly for identifying problem frames, whether it's like the frame before a bug happens or the frame that a particular bug happens. So then I could go in and sometimes in code on the fly, just add a breakpoint at that particular frame so that, you know, I break there and then I could inspect that. All right. So thank you for watching. I hope that this was educational for you and you took something away from it, because I've even had people that have come to me after I showed them this method and they'll tell me that this helped them resolve some bugs or identify some nitty-gritty problem that was happening. And I think it is definitely something worth implementing for debugging on top of those other more fun like actual game features that I had mentioned, such as having an attraction demo or having some type of best record replay capture mechanic. So if you missed it the first time, my name is John. I hope this was helpful for you. and I hope you get a lot of use out of implementing this.